Hello, this is Algebra 2, Lesson 10-4 about ellipses. And our objective for this lesson, we're going to split it up into 2 days. We're first going to write the equation of an ellipse. We'll do that today, part 1. And then we're going to learn to find the foci of an ellipse. And then we're going to learn to graph an ellipse, which will be tomorrow. So before we begin, I'd like for you to work some bell work about solving equations. So when we solve, what are we doing? When you're solving, you're finding values for your variables. So work problem 82, 83, and 84. I'm going to give you 3 minutes, and then we'll move on into the lesson. Begin now. And I'll give you a little push start here. Set these equal to 0, right? So you're going to have to add 18 to each side here. And so you'll end up with x squared plus 11x plus 18 equals 0. Now you've got to factor this. So can you do a magic x? You're going to complete the square, use a quadratic equation. How are you going to factor this? So I would think you're going to use your magic x. What 2 factors of 18 add up to be 11? 9 and 2. Right? So this is going to factor to x plus 9 times x plus 2 equals 0. Now what makes each one of those true? Remember our zero product property? So it's going to be x equal negative 9 or x equal negative 2, and that's your solution. So I've worked 82 for you. Now use the rest of the time to do 84 and 85, which are equally as easy. This is probably going to be the squares, and this you're going to have to factor out an m, and then see if you have a difference of 2 squares. And this one's probably going to be a perfect square trinomial. So factor those quickly, and we'll move on. Seconds remaining. Okay, so I gave you a little push start there. So we already know that one of the solutions for this one is m equals 0, right? For that one. But this one, you've got that's a perfect square and that's a perfect square. So it's a difference of 2 squares, right? And then let's look at, I cannot read this. Whoops, wrong one. Come on. I'm just having bad luck. There we go. Alright, so when we look at this one, we've got to put this in order. So subtract 12p squared from each side, and you're going to get p to the 4th power minus 12p squared plus 32 equals 0. Right? So you have to look at this. Does this follow that perfect square formula? So is that a perfect square? And is this a perfect square? Well, they're not. So what should we do? Maybe we should complete the square. Right, so think about how to factor those, and if you have enough time, if you're not finished, come back to it at the end of class. So we've talked about circles, and although today we're going to move on to ellipses, we need to understand, a circle was a set of points, a fixed distance from one point. So if we had a center here at the origin, we could pull a string out and make a circle. No matter what, it's the same distance all the way around. Well, for an ellipse, it's not. An ellipse is a circle that's stretched in one direction. Okay, so it is a set of points that have a total fixed distance from 2 points. So again, an ellipse stretches a circle in one direction, and it is the set of points that have total fixed distance from 2 points. So it could be stretched out this way, it could be stretched out this way, right? So it's from 2 points. Right? Like that and that. So let's look at what this is about. So here's a key concept for an ellipse. By definition, an ellipse is a set of all points P in a plane such that the sum of the distances from P to 2 fixed points, F1 and F2, is a constant K. A focus of an ellipse, and the plural of focus is called foci, is one of the 2 fixed points. A focus of an ellipse is one of the 2 fixed points. So that will be our foci. Excuse me, our focus. Plural is foci. So we're talking about a focus because it's one of the 2 fixed points. So here it is in our symbols. So we're going to have P, and notice that these are capitals, F sub 1 plus P F sub 2 equal K. And then they go on to say where K is greater than F1 times F2. Okay? So here's our F1, here's our F2. So these are our focus points. So what they're saying is that the sum, if we pick a point and we measure it to these 2 points, to these 2 foci, or to our 2 focus points, when we add these together, it's going to equal a constant. And then if we pick another point on the ellipse and we add the same distance to those 2 focus points, it's going to be the same. No matter what point we pick, it's going to add up to be the same number. Okay, which is that constant they're talking about, K. All right. So we go on, here's some more information for you. The major axis, we've got a major and a minor axis. The major axis is the segment that contains the foci and has its endpoints on the ellipse. So the major axis is the one that contains the foci. So for here, there's our focus points, F1 and F2. So this means that's our major axis, which would make the other one our minor axis. Okay. And let's look over here. Where's our focus points? There's our focus points. So that means this is our major axis. The major axis is the ones that contains the foci and has endpoints on the ellipse. All right, there's our endpoints. Now, its midpoint let me go back. Now we're talking about the midpoint is the center of the ellipse. Okay, there's our center, there's our center. So now it looks like it's the origin, right? But the midpoint is the center of the ellipse. And the minor axis is perpendicular to the major axis at the center. So they are perpendicular to each other. They are at right angles to each other. So remember, the major is the one that has the focus points. The minor is the one perpendicular to that. It's major, minor. The vertices of an ellipse, the singular term is vertex. So now we're talking about two vertex, so it's called vertices, more than one, are the endpoints of the major axis. So there, at 0 and B, and 0 and negative B. Excuse me. Let me back that up. It's the major axis. I was on the minor axis. Here's our major. So let's say that again. The vertices of an ellipse are the endpoints of the major axis. So here it is. Negative A and 0 and A and 0. There they are. Sorry about that. The co-vertices of an ellipse are the endpoints of the minor axis. So that's our B that I was reading by accident just a minute ago. Okay? So now let's look at this one. Our major is here. So this means our endpoints are 0A and 0 negative A. And here, my minor axis, my co-vertices, are negative B0 and B0. Okay, so those are some things that we're going to need. And let me point out too, there's, just like we talked about horizontal and vertical, if I was to keep smushing this in the direction it's being smushed, it would end up what? A horizontal line. So it's smushing over the horizontal line. This is a horizontal ellipse. And same thing this way. This one's squishing in. And this one's going to be a vertical ellipse. If we kept squishing it in, it would be a vertical line. It's around that y-axis, vertical. Horizontal, vertical ellipse. So here's the key concepts and all of this put together with our equations. So here's our standard equation of an ellipse with the center at the origin. So remember we were talking about the vertices and the co-vertices, A and B. So here they are. So the standard equation is x squared over a squared plus y squared over b squared equal 1. And a is greater than b and b is greater than 0. Now that's for horizontal. Now for vertical ellipse, we've got, just notice what changes, the a's and the b's, reverse. So for vertical, we're going to have x squared over b squared plus y squared over a squared equal 1. And now it's the same thing, a greater than b greater than 0. So the only thing that changed here on horizontal, a is first, b is second. Vertical, b is second. Or b is first, a is second. They reverse. So now let's break this down by horizontal ellipse. So the major axis on horizontal is horizontal. And for vertical, our major axis is the vertical axis. And the vertices, positive, negative, a and 0. The co-vertices for horizontal is 0, positive, negative, b. And our foci is positive, negative, c and 0 on our x-axis. Then for vertical ellipses, our vertices are 0, positive, negative, a. Co-vertices are positive, negative, b, 0. And our foci is 0, positive, negative, c on the y-axis. So that's a lot to take in, but you'll start to see these pretty easy as you work through these problems. So take a picture of it. That's what I have. Take a picture. Yeah. If you've got a sub today, you might just politely say, if they ask you what you're doing, say that Miss Downey asked you to take a picture of what's on the screen. And then please put your phone right back up. Okay, notice at the bottom here it says the length of a major axis is 2a. That's important. The length of the major axis is 2 times a, and the length of the minor axis is 2 times b. So for any point P on the ellipse, P times f sub 1 plus P times f sub 2 equal to a. So now we've got lots of things to work with, okay? And you can, hopefully you've written this in your notes, and you will have to just have this out while you work through the first few problems, okay? But basically the lesson is just about taking this and applying it to what's asked of you. It's just straight algebra. The algebra 2 part is just knowing these properties and how to use them. So our first problem we're going to work on today, and make sure you've ripped out 10-4, excuse me, yeah, 10-4, that's right. 10-4 ellipses out of your workbook. It's practice K. And our first problem is all about writing the equation of an ellipse. What is an equation in standard form of an ellipse centered at the origin with a vertex of -6, 0 and a co-vertex of 0, 3? So we have to decide, is it horizontal or vertical? So if you can't picture it, draw it. So it says one vertex is -6, 0, so it's back here at -6. And the other vertex is at 6, 0. Well, that means it's this way. It's a vertex, not the co-vertex, so it means it is a horizontal because it's going over the x-axis. See that? If they had said co-vertex, then we would know it was opposite, but it's the vertex. So the vertex is on your major axis. So that is a horizontal. So we're going to use the horizontal information. So they tell us that our co-vertex is 0, 3. That means that the other one is going to be at 0, -3. So our minor axis is vertical. And I'm sorry, I should have written both of those down first. I thought about it and decided, and then I taught half of it. So you have to really look at both of them and decide which one's bigger. So this one was the bigger, so that's, well, and also they said that that's our vertex. So we know that's horizontal, and the co-vertex is perpendicular to that. So it's a horizontal ellipse. So our A value is equal to 6. Our B value is equal to 3. So from here to here, so that is our 6. And from there to there, that's our 3. So A equals 6, B equals 3. And A squared is equal to 36, and B squared is equal to 9. So those are the things that we need to know. So square them both. So we're going to do the x squared over A squared plus y squared over B squared equal 1. So that's your standard form of a horizontal ellipse. So you're going to fill it in. A squared is 36, so x squared over A squared, which is 36, plus y squared over B squared, which is 9, equal 1. So there's your answer. And that's how you write an equation of an ellipse. So let's look at your first problem in your workbook. These should take about 2 minutes each. Let's work the first one together. It says write an equation of an ellipse in standard form with center at the origin and the given vertex and co-vertex listed. Note that the vertex is listed first and the co-vertex is listed second. So that's the vertex and that's the co-vertex. So if our vertex is 3 and 0, and our co-vertex is at 1, it's going to be something like that. So our A value, this is horizontal, our A value is equal to 3, and our B value equals 1. So our major axis, it's horizontal, right? So here we go, the minor axis is vertical. So A is equal to, fill these in, 3, B is equal to 1. So A squared, which is 3 squared, which is equal to 9, and B squared, which is 1 squared, is equal to 1. So now, write your standard form, which they've done for you. There it is, of a horizontal ellipse. X squared over A squared plus Y squared over B squared equal 1. Oops. And now substitute for your A squared and B squared. A squared is 9, B squared is 1, so substitute those. Oh, okay, so now you're just going to finish the problem off right there. So it's going to be X squared over A squared, which is 9, plus Y squared over B squared, which is 1, equal 1. And that's your answer. See, it's not that bad at all. All right, now remember, if it's a vertical ellipse, you're going to switch your A and B values. So it would become X squared over B squared plus Y squared over A squared equal 1. So be careful of those. Now let's take 4 minutes, and I want you to work number 2 and 3. Let's start that now. Work them the same way. 1 minute left. Okay, so let's move on. Okay, so our next problem, problem 2, is about finding the foci of an ellipse. So now they're going to reverse the situation. They're going to give us an equation, and we're going to have to take that and decide where is the focus points, where are the two focus points of the ellipse on that major axis. So they give us what are the foci of an ellipse with the equation 25x squared plus 9y squared equal 255. Graph the foci in the ellipse. Well, wouldn't we just love to plug this in a graphing calculator and hit graph? And that would be so easy to do. But we can do this without that. So we need to know the equation of an ellipse, right? And then we're going to need the coordinates of the vertices, the co-vertices and the foci. So our plan is to write the equation in standard form, and so we can find our a squared and our b squared. Then we're going to use c squared equal a squared minus b squared to find c. So we're just using geometry, and then we're going to use a, b, and c to graph our ellipse. So start with our equation 25x squared plus 9y squared equal to 225. And now we want to divide everything by 225 so we can get that equal to 1 over there. So divide everything by 225 and we get our desired result there. So we're getting closer. It's looking closer to our equation for an ellipse. Now we want to simplify that to standard form, right? Because we know 25 goes into 225 9 times. So you get x squared over 9, and 9 goes into 225 25 times. So that simplifies to x squared over 9 plus y squared over 25 equals 1. Now we've got something we can work with. So since 25 is greater than 9, and 25 is with our y squared, then the major axis is vertical. See, that's the bigger one. And he's with our y, so this is a vertical ellipse. Okay, and that's another way to look at it, is to see what is the bigger number with. Is it with the x or the y? Whatever the bigger number's with in the denominator, that's your major axis. So if the bigger numbers are y-axis, that means that this y is, or x is smaller. The bigger numbers with y. So it is a vertical ellipse. So now that means that this is our A and that's our B, right? So A squared is equal to 25 and B squared is equal to 9, right? So our A is equal to 5 and our B is equal to 3. Actually, we don't even need to do that yet. Before we do that, so we've got A squared equal 25, B squared equal 9. So that means that A is going to be equal to 5, B is equal to 3. And now we've got to get our C. So C squared equals A squared minus B squared, which is 25 minus 9, which is 16. So there's our C. So take the square root of that, c squared equals 16, so c is equal to positive negative 4. So now we can graph this. Our foci are 0, 4, and 0, negative 4. So there's our foci in red. 0, 4, 0, negative 4. And our vertex is 0, 5, and 0, negative 5. And our co-vertex is, or vertices, I should say, co-vertices is at 3, 0, and negative 3, 0. Right, because A, that's our vertices, and that's our co-vertices. Now we've got enough to graph it. And then once you plot those points, then you graph it. Okay, so with this problem, on your worksheet, work 4, 5, and 6. And that's where we will conclude our lesson for today. So work problems 4, 5, and 6. And then what you don't finish in class becomes your homework. Okay? And that concludes our lesson for today. Thank you for watching. Oh, by the way, here's 4, 5, and 6. If you don't have your workbook with you, here they are. Okay, and this will conclude our lesson, and we'll pick up working 7, 8, 9 in the back page tomorrow. Thank you.